That one was from Mapachuro from Songs of the Limit, his kernel project. Thank you to Oliver for helping us settle in for week 5. It's been a big week. We did Expo. Thanks to everybody for joining. I think we have probably a smaller crew here for Fireside, given all of the big things that happened on Tuesday and Wednesday. Thanks to the 35 of you who presented, many of whom are on the call. So thank you for that. And we're really excited to have Tate with us for tokens and mechanism design. It's the module that I think has the broadest surface probably in all of kernel, and we think all of crypto. And Tate comes with a wealth of knowledge about a few token ecosystems that interweave that are called Arweave and AO that we think represent token design done well. So we're excited to get into them and learn from the conversation. There's a few things that we wanted to start with from this module. The first is on simplicity. And it's a topic that came up yesterday when we were exploring the module, because simple and complex are two words that have roots in threads and thread weaving. And in that root system, a simple thread is one that only has one line, and a complex one is one that weaves together multiple. And we offer that a lot of the times what we're aiming for in token design is simplicity, and that ends up being worth a lot more than any type of complexity. And we kind of follow a branch of computer science in the beginning of the token module that comes through the Clojure community and a man named Rich Hickey, who started that specific computer language. And we come to this simple definition of tokens with his help, which is tokens transmit information about facts. Tokens transmit information about facts. The things that we use to get there are kind of here at the beginning of the module. The computer science definition for a token was the smallest meaningful unit of information in a sequence of data for a compiler. There's another definition from computer science, which is a sequence of bits passed continuously between nodes in a fixed order, enabling a node to transmit information. And then a little bit further, a token is some object, word, or sequence which authenticates knowledge or possession of some fact, which grants the holder certain privileges. So most succinctly, again, we get back to tokens transmit information about facts. The hope with starting with this is to just open our eyes to the possibilities that still remain within the field of token design and mechanism design, to suggest that we might have many more places that we can go than we've already been in the first 10 years. So I think that's what I want to do in terms of introduction. There's a few other things that we might get back to in this module about incentives and listening and more pro-social design for tokens. The module leans upon this idea that listening and narratives are as important in tokens as the simple design. But I want to do so with Arweave and AO as an example. And I think what I'm going to try to do, Tate, is I'm going to try to do a V1 and then see if we see if that jumps us off into conversation. But
Oh,
first,
great.
thanks for
Oh,
being.
sorry. Of
No, not at all. Thanks for being here.
course.
Um, so the starting point there would be if there's a story that Arweave represents, and we'll get to AO. The story is um, that I've understood is that permanent data storage that you own and can purchase is something worth considering. You purchase storage from Arweave, uh, which is a network like Bitcoin, but for data. And you're able to guarantee that that information is going to be stored on a variety of machines around the world and be accessible for at least 200 years. And there's a lot of uh, fun but simple mechanisms that go into making that possible. And we might talk about some of them today. But from a narrative perspective, the simplicity is that if you want a place where you know you could access this information in 200 years, but perhaps further, Arweave represents one of the best possible solutions. Um, so this is the place that I think the AR token starts from. Um, as you dive down the rabbit hole, you start to ask some questions that I hope that Tate can help us answer a little bit, which is just kind of like, why? Like, why would you want to purchase this storage when it's perhaps a bit more expensive than renting for a long, at least on the short term? What type of data is the data that you would really want for such a long period of time? Um, but the next part that I think is also worth bringing in here is that, like, seems like having this storage network also had a really big impact on realizing that there's more that you can do when there is such a strong guarantee of permanent data storage. And it took a lot of years of research. If Arweave's been around for almost a decade now, perhaps a little less, AO, which is the hyperparallel computer, has only been around for about a month and change now. And this supercomputer is quite unique even within crypto. It is not a blockchain. It does not make guarantees that every, let's say, node in the network is going to have a sense of shared global state, but it does make the guarantee that uh, those state uh, that state can be put back together. And AO also has a relatively simple token design that's built upon the permanent data storage token design of Arweave. So before asking Tate to help fill in the gaps and take us further, I just want to give him a little bit of an introduction. We've been really lucky to have gotten to see Tate through the years, and he's only done great work pretty much every step of the way. I love the playing long games that he puts in his bio. It reminds me of the pro-social games narrative that's in this particular module on tokens. He has his personal website on Arweave. He's building community labs right now, which invests in projects building on Arweave and AO, but Tate himself is also a builder and is involved at community labs in building the first exchange stablecoin lending protocol and helping build some of the consumer apps that are being built on AO, the decentralized supercomputer. And he spent many years doing great work in the Arweave ecosystem. So one of few people, I think, who could really help us understand what's going on here and what's elegant, what's simple, what's exciting about the token design within this ecosystem, and also how it compares to some of the alternatives beyond it, to try to help us just put into perspective like what is possible here uniquely in the Arweave and AO case. So thanks for being here, Tate.
Thank you for having me. It's great to be back. I don't know if it'd be helpful, but I put a deck together, and I'm happy to go through that if you think that would be a good way to kind of get things started.
Let's do it.
Cool. Let me just share my screen. Can you guys see this?
We can see it, yes.
Okay. Let me just organize things on my side here. Cool. So yeah, thanks again for having me, Vivek, and for the intro. It's really great to be back. In today's conversation, I wanted to talk a little bit about mechanism design and token economics. To be frank with you all, I've been building as an engineer for the past few years, 8 years in crypto, 5 years as a founder, building community labs as a software development company and venture studio focused on building out and bootstrapping different verticals and use cases of Arweave and permanent data storage, and now AO. Also building on Arweave generally, just because humanity's existed for 300,000 years. And throughout that time, the best way we've managed to guarantee information availability is through cave drawings and religion. Needless to say, if we're going to be around for another 300,000 years, I feel like we need a better system. And Arweave is super interesting to me because it puts mechanism design in practice to deliver an architecture that creates incentives around storing data in full fidelity for at least 200 years. But it's looking like it'll be far more than that at the current economics. And I was also a fellow of Kernel Block 3, so it's exciting to see how the program has come over the years. Excited to be back. One other point that I didn't put on this slide that I probably should disclose is that I'm also uneducated, which means that the experiences that I have with mechanism design and token economics are purely from my own experiences. There are a lot of rabbit holes that you could go down with this technology because it is so broad, to Vivek's point. And I'll go down a few rabbit holes that I find especially interesting, but I don't want this to be considered as something fully comprehensive. And I'm also still learning in real time, like everyone here. So I could be wrong about this stuff as well. With that said, though, mechanism design is the science of engineering humans to do useful things with minimal management. I think that's an interesting definition because it sort of accounts for a very broad scope of what mechanism design can be used for in humanity, but also it takes into account the idea of game theory, which sort of exists at the intersection between psychology and economics as a way to predict human behavior. Mechanism design is essentially taking game theory and creating games to incentivize humans to do certain things without needing to have some type of management because it relies on self-interested parties acting in their own self-interests. That's a lot of broad definitions, though. I think the important point is that how does it work? Sam Williams gave a talk a few years ago that I commonly reference back to. And at the end of this talk, I'll have a QR code that you guys can scan because I don't think I will ever do as good of a job as he did at explaining it the first time around. Sam also happens to be the founder of Arweave, which is kind of a funny coincidence. But in Sam's talk, he laid out sort of 3 steps to building a mechanism design or thinking about designing a game for a mechanism design problem. The first step is to identify a goal. The second is to build a reward mechanism and vehicle for that reward mechanism. I'll go more into that shortly. And then the third is a reward function. The way I like to think about these three steps, maybe reworded a bit, is starting with a goal, thinking about a way to earn a reward, and then thinking about the way to essentially calculate or evaluate or keep into check the reward itself. That keep into check part is very important, and I have some examples that'll explain the reason why that's important soon. But it's also important to note that mechanism design is everywhere. I think about mechanism design when I'm looking at anything in the world, because the world that we live in is designed for humans, and humans have a way of creating mechanisms for other humans. It exists in capitalism at the widest scope. The goal for capitalism is to encourage the growth and prosperity of humanity. How does it do that? It creates a reward mechanism around incentivizing people to create things that other people want. And the vehicle for that reward mechanism is money, is capital. Capital flows and reallocates to people that manage to create things that other people want. And the function for that reward is incentives around profit maximization. You have an incentive to accrue capital. You want capital as a human because capital buys you optionality to make decisions when other people are playing by the rules of the game as well. You also are incentivized to compete with other people if you believe that there is an edge that you have against someone else. Capitalism is perhaps one of the wider scopes, so you could talk about this for hours, but I just wanted to note it as a specific macro angle, because a lot of this talk will kind of narrow down into specific games for mechanism design. But it's important to note that like mechanism design really is everywhere. Another very small example that I actually had a pretty rough experience with a few years ago was potty training a puppy. The interesting thing about mechanism design is that it also applies to beings that aren't human. The core difference is that the reward vehicle is different. But for humans, obviously we want to keep the house clean. That's our goal. The reward function is for a dog to use the bathroom outside as a way to keep the house clean. And what incentivizes the dog to do that? Well, they get a treat. They essentially have positive reinforcement. So if they use the bathroom outside, they're rewarded for doing so. And I'm keeping that into check by looking for proof. I want to make sure the dog actually used the bathroom outside, because if she didn't, she'll learn that she can just go outside and not use the bathroom, get a treat, and then go inside and use the bathroom. Calling that proof of potty, because I don't think that mechanism is documented anywhere else for now. But that's all to say, this stuff exists at all scales. Now, the interesting thing about blockchains is that they enable tokens as reward vehicles. I think the way that Vivek outlined tokens in the kernel block is interesting. For the sake of this conversation, I think about a token as a reward vehicle, as a way to create a unit of value that we can use to reward people for doing certain types of tasks. The other thing about mechanism design is that it's really, really hard to do well. I have a bunch of examples of this. I want to go deeper on sort of three categories of why it's difficult to do well. And also starting with categories that exist both inside crypto and outside crypto. Why is that hard? So economic incentives shouldn't outweigh moral incentives. That's one of the first cases when you have this new reward, a vehicle of reward. You now have a moral reward to follow some type of mechanism design, and you also have an economic reward. And those things at times can compete against each other. And that becomes very dangerous in practice, because you can wind up in scenarios where people are actually financially incentivized to essentially contribute to deforestation, because the profit that they can earn for the wood that they're chopping down is greater than the moral incentive that they might have to keep the forest there. It also exists in technology. Apple has an incentive financially to slow down old iPhones as a way to incentivize people to buy new ones. It exists in pharmaceuticals as well. I think that this is another rabbit hole, but there are a lot of cases to be made for medications not being expensive. But when you wind up in scenarios where companies are, you know, essentially having monopolies over production of certain types of medicines, you're able to, look at these corporate pharmaceutical groups having incentives financially to raise the price, which morally is wrong because it might prevent some people from actually getting access to treatment that they might really need. But yet here we are, we're in this world where these things happen quite often, and it's definitely a problem. Another problem with mechanism design, although I'll caveat this one, is that humans are irrational in that we aren't purely rational all the time. That's interesting because in theory, we have an incentive to always eat healthy if we're acting purely off of logic, because we know that maybe eating healthy will help us to live longer and more prosperous lives. People also love to gamble, even though they know statistically the odds are against them because they enjoy the thrill of actually gambling. We see this with TikTok. You spend time doom scrolling on your device while, that's not really benefiting you. It's giving you a short-term thrill. And then there's also a level of, I guess, lack of logic with branding and the experience that you have by associating with a brand that you can't quite quantify, but that you use to justify buying a $2 million Bugatti when you could be buying a Toyota Prius to get you from point A to point B. The third problem is that for crypto specifically, the implications of these mechanisms are far more serious on decentralized networks because it's very difficult to actually change the game when you have deployed something through a smart contract or when you are building a blockchain or building a decentralized network. A good example of this is Beanstalk. So this is actually a really wild story. I don't know how many of you have heard of Beanstalk, but personally, Beanstalk was one of my favorite projects aside from Arweave a few years ago. They were creating essentially an algorithmic stablecoin that, in my opinion, actually made sense and would be able to sustain itself. And you can read the white paper of Beanstalk. It's probably worth doing just as an exercise to understand how they thought about game theory and mechanism design as well. But Beanstalk had a DAO, and as a part of the mechanism design, the DAO would essentially be able to vote on passing proposals around improving the protocol with time. What they didn't account for was there was no function that established a quorum. And so people participating in the mechanism design around Beanstalk discovered that there was an incentive to essentially flash loan a bunch of capital to meet the 67 or 66% requirement to pass a vote, and ignore the requirement of quorum. And in practice, what this did is it enabled an attack vector where someone could take a flash loan out, pass a vote, and actually drain the treasury that was powering Beanstalk. Obviously, for a decentralized algorithmic stablecoin, that is not a behavior that we want to have incentives for. But yet, because Beanstalk didn't consider that when they were structuring the DAO, this incentive emerged and people took advantage of it because they were a self-interested actor acting on logic. And they were able to really take advantage of that. I think that, again, you could also categorize this in the bucket of maybe people should have moral incentives that outweigh economic incentives. But this was a very extreme case because I'd imagine people would be willing to do a lot for $182 million if they could find a way to get it. Good mechanism design creates incentives for the most rational actors to win. this is sort of the caveat to one of those other problems around humans being irrational most of the time. If you can create an incentive mechanism that rewards rational actors, you've also created an incentive mechanism to encourage irrational actors to become rational, to be able to win the game. Um, One example of this is the prisoner's dilemma. So, take for example, you have two people that committed a crime together. They were taken into custody by law enforcement. The detectives have separated them to be able to interrogate them separately. And in each of those interrogations, the detective approaches each prisoner individually and says, look, we would be willing to give you freedom in exchange for testifying against the other prisoner. Um, Now, the interesting thing about this dilemma is that each prisoner has an incentive to testify against the other. The dominant strategy to win the game becomes testifying against the other person. The problem with this, however, is that both prisoners are now incentivized to, I guess, essentially talk against one another, to claim that the other person was responsible for that crime. And the interesting result of this game is that if that dominant strategy plays out, both prisoners actually end up receiving prison sentence, because they're both guilty of a crime that they're both attesting each other did. Um, Now, in another case where no prisoner, I guess neither prisoner decides to talk against the other. Um, the interesting thing about that is that you're that outcome would lead to the lightest sentence. However, you don't really have an incentive to do that, because can you actually trust in a silo that the other person will do the same thing as you when the dominant strategy is for someone to, to confess? Um, yeah, it's super interesting. Another example is BitTorrent. So BitTorrent in the early days actually accounted for a large amount of the internet's bandwidth, and a large amount of the interactions that occurred on the web. And it worked with a very simple mechanism called optimistic tit for tat. And the idea behind the way BitTorrent works is, if you are essentially a participant in the network, you have an incentive to share information with other people, other participants in the network. It's obviously that it's more technical. It goes deeper than this, but for the sake of this conversation, the general idea is that you have an incentive to store data and to share data with other people that might not necessarily be directly relevant to you. And the reason that you have that incentive is because if other people have that incentive, they can help you get information. In other words, if the dominant strategy out of the gate is to encourage cooperation and to incentivize cooperation, then the most likely path that all the other parties will take is cooperating. And in practice, what that did is it created this giant network of people that were sharing information. And it was a really powerful but simple mechanism design that worked really elegantly. So I think it's worth noting that one as well as something that's a lot of crypto native mechanisms, I think, are inspired by. I'll talk a little bit more about that too. So going back to Arweave, if we're thinking about this in terms of those three steps, the goal of Arweave is to enable people to store data permanently and securely. The reward mechanism for that is users pay to an endowment for storage, and miners earn from that endowment over time for being able to prove that they're storing. And this is where the reward function comes in. You don't want the endowment to just drain itself for the first person that proves they're actually storing data on Arweave. So Arweave came up with this mechanism called Spora, which stands for Succinct Proof of Random Access, that essentially requires, well, it doesn't require, it requires proofs, but it doesn't require that everyone actually have to provide the proof. It just creates an incentive for people to provide these proofs that they're storing the current block and one of the previous blocks at a given time. There also, it's worth noting, you should read the white paper of Arweave. This is an oversimplification of it, but that's the general idea. And there are some implications to this design that, while simple, I think are worth talking about. One of the cool implications is that the endowment is positioned to distribute tokens over an extremely long period of time, at least 200 years. And so what that means is that as people are using Arweave and using the mechanism that powers Arweave, they're actually locking these tokens up for 200 years when they're paying for storage. It also incentivizes miners to replicate as much of the data set as possible. But the cool thing about this is that it doesn't require them to. It just incentivizes them to. And I'll talk more about that in a second as well. And similar to BitTorrent, as a miner, you're also incentivized to gossip with other miners. You're incentivized to share information and share data and to collaborate so that you can optimize the chances that everyone will be able to earn a reward for, when a new block is produced. The other cool effect of this is that miners compete to offer the lowest cost of storage to the user. So over time, what that does is it creates ways for the cost of storage to actually go down as the cost of maintaining that hardware becomes cheaper over time for miners. That creates a better user experience for people that are using the mechanism, and quite different than something like, Ethereum or Bitcoin. It doesn't rely on token price increasing to sustain itself. It doesn't require a market, or it doesn't rely on volatility to sustain. It also doesn't rely on miners being able to store the entire history individually. To talk more about this one, because I think it's really interesting. There's really two reasons why we don't want that incentive to exist and why it's good that it doesn't. The first is that as Arweave grows, if we create a requirement that miners store the full history of Arweave, eventually it will centralize itself because it will become incredibly difficult for any individual party to store the entire history of Arweave. So you would essentially see the game theory of that would be the cost to actually participate in the network would increase to a point where it would centralize itself. That's bad. The way it works is much better. The other case, the other reason that this is good, to point back to the point I was making earlier around you don't want moral incentives to underweigh against economic incentives. Essentially, anyone can upload anything to Arweave, but is that actually a good thing? What happens in the case where someone uploads some type of content that you really don't want being stored in the network? For instance, like child pornography, something illegal. The cool thing about this mechanism is that nodes actually have a greater incentive to abide by the laws of the jurisdiction that they're operating from than they do to store data on Arweave in exchange for a reward. So what that means in practice is that people can make opinionated decisions participating in the network about what types of data they do and don't want to store and contribute to the network with. They're able to be rewarded for storing as much of the data as possible that they're willing to store, but they aren't required to. And the other note is that it doesn't incentivize storage price increases in proportion to usage. So pointing back to Bitcoin, for instance, when Satoshi set the 1 megabyte block limit, you have this really weird mechanic where all of a sudden, a few years later, Bitcoin is being used a huge amount. But because of that block limit, instead of being incentivized to update the network or to increase the capacity of the network participants actually don't really have that incentive, because what it means is the participants of the network, or rather the users, are essentially bidding against themselves to be able to get into one of these Bitcoin blocks, which in turn increases the reward to the people that are actually powering that network. They're able to make more money as the network becomes more congested. And that's not good. That's not something that really scales in a way that we want, because that sacrifices user experience at the cost of increasing profit margins for network providers. Arweave doesn't do that. As Arweave is used more, storage price does not increase in proportion to usage. It's incentivized to decrease. The other really cool outcome of this that's actually quite new, it's more recently being seen, is that Arweave becomes deflationary when more fees are actually coming in for data being stored than what goes out to reward miners for proving that they are storing that data. And that's really cool because the economic mechanism behind that essentially reduces the supply. It helps to increase scarcity, which I don't want to speculate. Who knows what happens with the price of the token? But it's good to decrease supply when you can, rather than to inflate a supply of something, I would say, in these types of situations. To talk more about AO, AO, the goal is to offer secure, generalized compute to as many people as possible. Um, the reward mechanism for that is that users pay for compute work, and the nodes earn for being able to prove that they're running computations. How are they proving that? The reward function is a process called AOSEC. There's also a staking mechanism there that incentivizes nodes to be able to prove that they are, or rather, not to prove, but to incentivize nodes to not act against the network because they would lose something if someone else was able to prove that they did. And there are also TEEs that enable you to create proofs of work being done without necessarily needing to show the work itself. This is really powerful because it means that, well, sorry, maybe to step back for a second, the what I call a node on AO, we call compute units inside of the ecosystem. Compute units are incentivized to provide results quickly. And one of the ways to provide those results quickly is to cache the results of the computation, to store them locally so that if they're asked upon again, they don't have to prove, or they don't have to reevaluate what those results would be. So it creates an incentive for them to provide those results quickly, which also in turn means that it costs these compute units less to operate if they are caching results that are being asked of frequently, which creates cheaper compute to the end user. It also creates the same mechanism similar to Arweave, where it's a free market and compute units are competing to offer the lowest cost to the end user to get work done, avoiding one of those Bitcoin or Ethereum-like scenarios where people start having to bid against each other for a fixed amount of bandwidth that the network can actually hold. And it's also easy to augment and upgrade. AO at its core is actually a protocol. It's not necessarily a decentralized network. However, people are building a decentralized network around it. And the cool thing about AO's mechanism design is that because it's baked into the protocol layer, it's actually much easier to augment and to change and to scale the protocol layer than it would be with a blockchain or something like Bitcoin. You don't have to hard fork things to be able to improve the way the system actually works. As long as you abide by the rules of the protocol, people are free to build their own implementations. The other interesting outcome of this is people can build implementations in different programming languages. People can build implementations in programming languages that the default version of the protocol doesn't even, it wasn't even designed for. Things compile down into WebAssembly at the core of this current iteration of the protocol. And so what that means is that, over 40 programming languages can actually be used to interact with AO. And I also know of a team that are building a Solidity interpreter as well, so that you could take your Solidity EVM contracts and port them over into the ecosystem. That's another one of those very technical engineering rabbit holes that I'm happy to talk about with other people, but maybe for the sake of this, I won't go into too much detail on. Let's talk about implications of the token itself. So AO's token was a little bit different in structure than Arweave's token, but I think it's worth mentioning for that reason. It was 100% fair launched, which means there were no insiders. There was no one participating that was able to get allocations of the token before other people. There was also no requirement, or rather, this also creates the lack of requirement for a core team or a central team to dump on the community as a way to afford runway for themselves. I'll talk more about this in a second. 2/3 of that token supply are allocated to what we call a pre-bridge, and 1/3 are allocated to Arweave token holders. What that means is that people, to participate in earning AO tokens, you have to deposit tokens into a pre-bridge, specifically yield-bearing tokens. Right now, it's staked ETH and DAI. And the yield from those yield-bearing assets, you essentially agree to forfeit in exchange for AO tokens. What that means in practice is that the core team building AO are able to earn yield from the deposited yield that people are putting into to earn AO tokens in exchange. In other words, maybe to simplify, this leaves the core team with tokens that are not AO tokens. So selling them doesn't actually put sell pressure on the AO price and risk damaging the community. 2/3 are allocated to that. 1/3 are also allocated to Arweave token holders. So Sam and the team behind Forward Research that built the Arweave protocol are building AO. They wanted to allocate 1/3 of the yield, or rather 1/3 of the AO token supply to Arweave token holders so that the existing community is incentivized to use and contribute to AO over time. This token supply, it is 100% fair launch, but it's also being emitted over, a long period of time, similar to Bitcoin. But the difference is that you don't have halvings. The curve is much smoother, so you don't have periods of time where large amounts of the token supply are entering the supply, or rather entering into circulation. A third component that is worth noting is the PermWeb index. So the interesting mechanism designed for the PermWeb index, the goal is to help ecosystem teams, people that are building on AO, sustain themselves. How does it go about doing that? It essentially enables people, if you're earning AO yield, either by holding Arweave tokens or by having assets deposited into the pre-bridge, you're essentially able to redirect that AO yield that you would be earning into the PermWeb index. And in exchange for doing that, you earn Pi tokens, and the teams that are participating in the PermWeb index earn AO tokens. Pi, the way it works is 30%, or rather, 1/3 of Pi is AO tokens, 1/3 of Pi is Arweave tokens, and 1/3 of Pi is ecosystem projects that anyone can participate in. Anyone can become a part of it. But the reward function for this mechanism is volume weights. So essentially, if you're asking the question, how do you determine the amount of yield that goes to one team over another that are participating in the AO network, that are building on AO, participating in the PermWeb index? It's volume weight. So other people that are choosing to direct their AO yield directly to those teams are essentially placing a weight on the teams that they're directing that yield to. So for instance, if there's a team called Base Jump and 1/3 of all of the weight of all the capital is being directed to them, then 1/3 of the PermWeb index component allocated to teams gets directed to them as well. As you can tell, I haven't found a great way to explain this concisely, but I'm happy to answer any questions that you guys have along the way. I think what's probably more relevant, though, in the meantime, is talking about the design implications of it. So users are actually incentivized to weight or allocate their yield to the projects that they believe to be the highest potential. So for the sophisticated actors that don't want an index approach into getting exposure into the ecosystem, those users are incentivized via methods of capitalism to allocate their yield to the projects they believe in the most, similar to venture funds. And the cool outcome of that is that Pi copies what those allocations are, weighted across the amount of capital that people are depositing. So Pi is essentially optimizing the yield weights over time to allocate towards the highest potential projects by looking at what other people are doing in real time. AO token holders are also by nature, by default, receiving exposure to the ecosystem directly. That's really cool because if you hold AO tokens, now you're able to get exposure to people that are actually building on AO rather than just having the AO token itself. And ecosystem teams become ecosystem aligned with this mechanism too, because they're now earning AO tokens to sustain themselves. They're able to earn essentially an allocation of the AO token supply as people are weighting their AO tokens or delegating their AO yield to those teams, um, which incentivizes them to act in the interests of the ecosystem as a whole. I think that's pretty cool. Um, Another question that comes up pretty commonly is, what are the implications of having two different types of tokens, one token for data storage and one token for compute, and why aren't they the same thing? Um, well, they're two different mechanisms, and hopefully that's clear now. They have a complementary design, though, in that Arweave ensures data permanence, and AO enables the computation on top of that data. It enables you to do things with the data beyond just store it. And this is mutually beneficial for each protocol because as AO is used more often, that drives demand for Arweave tokens and Arweave storage because all of these messages, all of this information is recorded on Arweave. And Arweave, the way that it operates, essentially acts as a settlement layer for AO applications. It enables AO to not have to worry about data storage. It simplifies the mechanism, which I think is actually quite elegant. It's nice to separate compute and storage because really you're having to optimize for two different goals. And most blockchains, they either don't account for one or they lump both of them together, which we're finding to be at least a little bit more monolithic than the way Arweave and AO are designed currently. It also enables some pretty unique capabilities. So Arweave sort of acts as a layer zero for layer ones for the networks that don't bake in incentives for the nodes to actually store the data or store the history of the chain. Arweave is able to do that for them. It acts as a data pipeline for oracles, transmitting data on Ethereum or other ecosystems. I'm sure you guys know more about it than me. It can be quite expensive, and Arweave creates a design that is meant to make that as cheap as possible, as viably possible. And so it makes sense as a place for oracles to live. One of the larger oracles called Redstone is based on Arweave for this reason exactly. Because AO is generalized, the goal is to offer generalized computation, and it runs with WebAssembly. You can actually run large language models inside of AO completely on chain for the first time ever, which is super cool. And also because of the TEE infrastructure that can also be built on top of AO, you can have people generating private keys and signing transactions from inside of AO processes that could then be used to interact with other blockchains. And in practice, what this can do is it can enable cross-chain agents that are intelligent and don't require liquidity to be on AO. You can take advantage of liquidity in other places because these processes are essentially acting as people themselves. And yeah, it enables a lot of real world applications and future potential use cases as well. So I won't talk too much about this. I feel like I'm going on now, shilling Arweave and AO too much, but I really do believe in the stack and have spent the last quarter of my life building it. So excited about that too. All that to say, Arweave and AO are operating with the ideology that genuine revenue powered by real use cases is critical to build an ecosystem designed to last. The game is not to make the token go up, even though we live in a world where a lot of people have an economic incentive for that to be the case. What we believe is in the long game, which is solving problems for people and being rewarded for doing so, creating things people want, and targeting unique use cases of the stack that we can offer that no one else really can as a way to do so. What I'll leave you with is that Bitcoin is better than gold. If you compare the mechanism designed for Bitcoin to the mechanism designed for gold, Bitcoin, I believe, is superior. because gold does not account for the fact that you are incentivized to look for gold in as many places as you can. And we have no way of knowing how much gold is actually out there, not just on Earth, but in the world more generally, or rather in the universe more generally. Whereas with Bitcoin, it relies on, cryptography to make sure that only a certain amount of it can be in existence. That's as simple as it gets, but I think a beautiful use case that sort of triggered all of this that we're working on now. So I'll leave with that. Yeah, thank you. If you're interested in seeing Sam's talk on mechanism design, which is definitely better than mine, there's a QR code if you want to scan that. If you have questions, you know where to find me, and also happy to talk more if there's more time here.
Yeah.
But just wanted to say thank you again. Yeah.
Thanks so much, Tate. Yeah, there's been a wide and great scope of questions in the chat, so I'm gonna try to pass the mic as quickly as possible. I know Adam, Acacia, and a couple others, so please, if anyone just would like to unmute to get started, I think we can move through some good questions quickly.
I could go. So this is probably a dumb question because I'm pretty ignorant of both FVM and Filecoin, but I was wondering if there's any parallels, similarities and differences between the relationship between AO and Arweave versus FVM and Filecoin.
Sure. Yeah, I mean, I think um, at a high level, you could say that the goals are relatively similar, and that both are trying to offer decentralized storage options, and create essentially a stack that people can use to build decentralized applications with. The way they actually go about doing that, the reward mechanisms for Filecoin and FVM and Arweave and AO are quite different. Arweave optimizes for storing data permanently so that you can rely on it being there as a sort of a source of truth, if you'd say. Whereas with Filecoin is sort of pay as you go. There is a team building essentially a permanent data storage alternative on top of Filecoin called Lighthouse. However, the economics there are not quite as designed to be as long term as Arweave. Arweave really is trying to store data for as long as humanly possible, whereas Lighthouse, I think, is able to offer something around 25 years of storage incentives for that information to be stored. So I would say similar in goals, but the types of applications that you should expect to see on top of them will probably be different. Filecoin FVM is inspired heavily by EVM, and so I think that's another difference. AO is designed to be inspired by really nothing. The goal is to be generalized compute, so it could be EVM or it could be something that is niche and AO specific. This is another thing that we could talk about a lot. So if you have any other specific questions about that, I'm happy to go into it. But yeah, spent a lot of time thinking about this.
Yeah, that did come up as well in the chat. Acacia had a question about how the global changes are checked against the cache. But Acacia, if you'd like, and then we also have some writing that Andy has done on this topic that I would refer to as kind of like a story of how it felt to use AO for the first time, which is really different from how it felt to use the EVM or run an Ethereum node. But go ahead, Acacia.
Yeah, I guess just to even back it up a little bit, it sounds like AO aims to be like a co-processor that you can invoke from a smart contract or something. Is that what you're saying? And there's like an LLM that sits on AO and you can like call it from the smart contract?
Yeah, I mean, I think that the interesting thing about AO is that it definitely can be used as a co-processor. A project that we're working on right now actually is positioning it as exactly that, where maybe there's like a value layer in Ethereum, but you want to be able to make decisions in a decentralized way that are informed by some form of intelligence. So for instance, you want like a large language model to consume information about, price history or some type of movement of a token price to inform a decision that should be made on chain. In this case, AO would be used as a co-processor to make a transaction on something like Ethereum. All that to say, though, that it doesn't have to be a co-processor. It could be something that you are using completely independent from other blockchains and other value layers. It's just to say, I think that's probably where it's starting right now. Yeah.
And can you give me an example of how because it sounds like it's generalized compute. So it's like it's a server essentially, and then you just have it connected or linked to this on-chain capability. Is it because you have like a verifiable compute, or like what allows it to do new capabilities?
Hey,
Sure.
if you'd like, one thing I did want to read from this because Andy had did some writing that I thought was really, really clear. And then Tate, please feel free to follow on. But he talked about the first time he used AO, and he did this writing on it called World Computing, a Work in Progress. It says the first and in my most important thing to understand about AO as it revolves around the system images, which seemed so magical when I first discovered them. Given that system images are just data, and RU is a permanent store for data, any system image exists immutably on the permaweb. It works like this. I start an AO process on my local computer, which gets an ID. That's a transaction on Arweave. Then transaction has some tags, one of which is called a module, which is also a transaction on Arweave. The data of that transaction is the system image for my AO process. It's a compiled POSIM binary. What's cool about this is once my system image is deployed, I do not need to keep anything running. It's there permanently. Arweave is the hard drive, AO is the CPU. I turn off my machine, go to the garden, hit the beach with my family, come back the next day. I resurrect the same permanent process, have it organize whatever compute I need to do. My process doesn't need to know anything about your process unless they directly interact. Instead of forcing global agreement about outputs, AO relies upon the inputs being stored in a permanent and public way. I'm going to skip ahead a little bit, but this is what the people who work on AO call holographic state. You don't need to compute over all the data all the time and have global agreement. If inputs are public and permanent, I can always reconstruct the state associated with any relevant process. The state is everywhere without actually being anywhere. Tate, would you have gone a different direction? Does that help in answering?
Definitely. Yeah, I think that what Andy wrote up there is quite good. Maybe if I had to add something, I would simply say currently blockchains are designed for the idea of like a globally shared state. And that, consensus mechanisms exist to establish what that state should be. And this is really good for financial systems. I think it makes a lot of sense to have these security mechanisms in place. But one thing that it kind of has difficulty doing sometimes is when you're trying to do things that are very complex in nature. And AO suggests that you can have a global state if you want. You can globally share a state if you'd like to, if you're building something that you think needs that level of security. But you don't have to. If you're doing something that is low in economic value or something that is high in compute, why require other people to do the same work to verify what you're doing? The idea is that if you want to build a truly scalable, permissionless compute layer for decentralized applications, you should be able to make that call. You should have that level of flexibility to decide how much security you actually need behind the transactions that you're trying to make. And it's a little bit hard to to explain because AO is just so different than what exists right now in blockchains traditionally. But the idea is that AO is trying to create a permanent operating system. I think to Andy's point, that you can plug into at any time that is more closely resembling the way your computer works than the way a blockchain works. Not to say it can't be a blockchain, it can't act as one, but just to say it's sort of inspired by a different source.
Gotcha.
Go ahead. Anyone who'd like? I see another question in the chat. Let's see. One quick one from the past was how expensive computationally and by price is it to run an LLM within AO?
So that's a great question. There are two different answers, I guess. It depends on if you're running the large language model on your CPU or GPU. If you're doing it from the CPU, if you're running inference on a CPU, it's going to be more expensive because it's going to take more time, and the CPU isn't quite optimized for that. However, there's a decentralized network building on top of AO called APUS, APUS.network. And they're essentially enabling you to run deterministic inference on GPUs inside of AO. And the goal there is to make it very cheap. That isn't live yet in production, and so I can't tell you exactly how much it costs, but what I can say is it'll probably be an order of magnitude cheaper than it would otherwise be to run the same compute from like a CPU inside of AO, and probably not even comparable to what it would cost to try and do something like that on another blockchain.
Would you be able to share the link to that project?
Totally. Yeah, they've done some really cool work around trying to make GPUs operate deterministically. It's actually quite a large problem, but they've managed to crack it. So if anyone's interested in the tech, they have good tech.
I'm also curious about some differences, similarities with Urbit.
Yeah, so let me preface this with I personally I don't have a ton of experience using Urbit myself, but what I can say is that that's oftentimes the first thing people compare AO to. I think it's similar in that, you know, Urbit believes in a local state rather than global state, and the idea of an operating system existing in the cloud makes a lot of sense. But beyond that, I can't say much more. I think that AO is designed to enable more because the way AO thinks about security, economic security, is a bit different than Urbit. But again, I can't compare and contrast the specifics because I haven't really used it myself in full transparency.
Okay, thanks.
Good earlier ones. Just a quick one, maybe on Arweave. It was a question from Adam, if you'd like, I think, on the resilience against Black Swan.
Yeah, sure. I was wondering, like, you know, if you're thinking about things in a 200+ year time frame, are you aiming to design for resilience against, you know, the biggest imaginable black swan events that you know, could have, you know, global impact in terms of, you know, power outages? So things like climate catastrophes, world wars, meteor strikes, like the really big stuff. I mean, obviously, if if something wipes everyone out, then all bets are off the table. But you know, if there's, yeah, you get the point.
Yeah, I think I was pitching Arweave in 2020 to a group of Web 2 engineers, and that was one of the first things they jumped to, which was, you know, if a meteor strike hits the world, my code probably won't still be on Arweave. And I would agree with you. I would also say that we probably wouldn't still be in existence. But maybe to more directly answer your question, yes, the way Arweave works, as long as one node is still storing the data that you're trying to access, everything still works. The moment when you can't say that, where there is no copy of the data across all of the nodes, you can't recover that, which is unfortunate, but it also sort of just kind of makes sense, I would say. So yeah, as long as there's one actor that still exists, you could still make the claim that it is, yeah, the network can function and can recover.
And just like generally on this, like why buy instead of rent? Like I think we can think about it, but I think what's useful maybe is for you to go into these unique capabilities when you talked about an L0 for L1s, like who is buying this permanent storage? We brought up Redstone. Like who are the main purchasers of storage at in wide chunks? Who do you anticipate might purchase more as AO's functionality continues to play into the story?
Yeah, that's a great question too. So to the answer of, or the question of why buy versus rent in general, the idea of buying immediately becomes a lot more attractive when you're thinking about using data for other purposes in low trust environments, or rather traditionally low trust environments. So if you're thinking about it in the context of needing to be able to hold people accountable for words that they've said, how can you rely in a rent only system? How can you rely on someone not being able to change or delete words that were previously said? Arweave aims to solve that by guaranteeing that something that you're putting up, or at least doing everything it can to guarantee that there will be incentives around the continued storage of that data in full fidelity. To be very concrete and specific, like if you're trying to store war crimes or evidence of war crimes happening in somewhere like Israel or Palestine or Ukraine or Russia, that is a group of users. Each of those have groups of users that are using Arweave for that case. If you're trying to share information in a country that's very censored, like China or Russia, that has a group of people that are using Arweave quite frequently to be able to get access to information that otherwise wouldn't be available, because it is censorable. The other, I guess, the other of the coin with trust is if you're trying data that you want to be able to rely on other people in the future. So AO is a good example of this, because if you are sending messages to a state in AO as a computer, other people need to be able to go and validate what you did. To see, they need to be able to, I guess, not have to trust that you're being honest about the state change that you made. In terms of people that are using it right now, I would say AO launched into testnet just over a year ago. As Vivek said, mainnet was about a month ago. It now accounts for a third of the Arweave transaction volume in just a year. So that's a significant usage driver of the network. Redstone as an Oracle, that's another situation where trust is very important. And you need to be able to rely on data being available and accessible without having to trust people to do that, or that to not change the data itself for purposes of market manipulation. And that's another use case where Redstone accounts for a huge amount of usage on the network, just because Arweave kind of perfectly solves that unique need that someone like Redstone or an Oracle provider would have. But in general, I think that, those are probably like some of the silver bullets and the most obvious use cases for permanent data storage in general. There are a lot of interesting side effects of that too, because there might be people that are using AO for reasons other than caring about low trust environments or decentralized environments. Maybe there's a world where AO is able to offer the cheapest compute to a user because the market for compute is far more efficient than it would be if you compare it to the current cloud providers that are offering generalized compute. And if that is the case, then all of a sudden, people that care about cheapest compute rather than just being able to trust that their data will still be there will now also be using Arweave inherently as well. So you could see a world where it has a tree effect. As more people compose on top of the data that's there, you also kind of open up the door to new types of use cases and reasons that may not even directly value the real important value propositions of Arweave in the first place, but still benefit from them.
I think maybe Daniel and Justin had a couple, and we're getting closer to time. Just Tate, let us know if you're good.
No worries. Yeah, happy to keep going.
So I will go ahead. It's okay for Justin. I have two questions. One more recent. The one I sent in the chat is how you deal with external with externalities when it comes to mechanism design, rather than positive or negative. There was a conversation between Acacia and Justin, like mechanism design shouldn't be unidimensional. Maybe it's a right question, a right answer, but yeah, I would like to discuss it further. And another question is more about utility, and if there's gonna be some point in the roadmap where you're aiming to build a sort of data marketplace. I understood part of you can run a query for a LLM there, so maybe setting up a data marketplace would be also something interesting to explore. Yeah, there are two questions.
Totally. I'm interested in hearing more about the one-dimensional versus two or three-dimensional externalities point. Could someone talk a little bit more on that?
Maybe I could follow up in like the other factor, like we are aimed to make the most rational decisions, but we never make rational decisions. So when we're talking about multidimensional, it's like you have maybe a financial incentive, but there's also a moral or an ethical framework that should be put in place in the design. I think that's where Justin Nakesh refers when it comes to multidimensional.
And I can jump in here, like at least my definition, and like Adam kind of did a great job of also adding some color to it. Tokens are like obviously the smallest unit of measure, and Vivek's like intro also like demonstrated that we reduce a token down to its simplest form. Well, then that thing can only represent one. It's like the smallest unit. So that smallest unit cannot represent like multi-dimensional like objects. So you have to decide what the purpose of that one-dimensional unit is. Do you want to use it as an incentivization mechanism for finances, or do you want to use it as an incentivization mechanism for something else? And then we have like from there the creation of NFTs. So you have like fungible tokens, which are financial, and then non-fungible tokens, which have different mechanisms. But even then, they represent one thing. So people are like, oh, it can represent a photo. So even though the photo is a lot of data, it's encoded down to the simple token object, right? You cannot put like dynamic. I posit or argue, and I'd love to be corrected here, but I don't believe that you can put multi-dimensional. And what I mean is that like multiple like vectors of interaction into one object. You have to like, and I think of it when like, and so I'm working on a similar project basically where I think about like holographic compute, but it's this encoding mechanism that allows a token to actually represent multidimensional items, and then the compute to be performed on the multidimensional items of that representation and not the token itself. So that's what I mean when I say that, is that you have to choose what that token represents And if you want it to represent something else, you can't just perform compute on the token itself. You have to perform the compute like in that higher dimension.
I see. I think I'm following you. Thank you for, yeah, explaining that further. And I think to respond to it, I would probably want to understand more specifically what you're working on and how it works. That's sort of how I like to understand how things work before. But maybe there is one thing that you said that I am relatively confident in. I think that it might be unfair to say that one-dimensional inputs can only have one-dimensional outputs. I think your wording was something along the lines of like a token as an input can't have effects across multiple dimensions. I would challenge that. I would say that what it can do is it can take into account the outcomes or potential outcomes across multiple dimensions and meaningfully or materially impact those. And I think that that's like a really important thing to recognize. To be very specific or concrete, to give an example, we are talking about this in the case of economics, and tokens are the smallest unit of value. They're very simple at the core, and I think that it's good with these types of things. Less is more. The simpler the mechanism, oftentimes the more robust it is. But it's important that we also consider the moral implications of the economic incentives that we're creating with the tokens themselves, which was why I was trying to suggest that you don't want to have an outcome where your economic incentive actually outweighs that moral incentive that you might want to that you just don't want that outcome. So I would say that when you're thinking about mechanism design, it probably is fair to suggest that like we're talking about this in one dimension, but the outcomes of these decisions are multidimensional and have multidimensional effects. And I definitely agree with you in that we shouldn't ignore that. But I'm incredibly interested if you're positing a way to have multidimensional inputs. That's very interesting. I'd love to learn more. Maybe that's like a separate conversation.
I would love to talk about it because half the time I feel like a crazy lady because I can't explain this. So you have like a great background, I think, to jam on this a little bit more, so I can always connect offline.
That'd be great. Totally. Do you think like from what I just said, can you poke holes in that? I'm curious. I might just be not seeing it completely in the way that you are and misunderstanding something.
No, what you're saying is that like if you have some token that is like sure like quote unquote one dimensional, the medium that you pass it through, and what you're saying is the token mechanism becomes a thing that represents multiple dimensions. And I think that works on like a case by case basis. So like, and this is what kind of happens in the crypto space is like everybody creates their own network and they have their own mechanisms and there's their own incentives. But I think that like is super segmented. And what I believe is the future of Web3 is that like I want my token to earn I want to use the blockchain as a coordination layer. I don't want to use it as some like token layer. And so I want to see the impact of like my actions on everything else in the system, because that's life, right? Like if I like mess up and I'm like working with somebody on this, like how do we represent like carbon sinks and represent the impacts of those carbon sinks on like multiple different things and incentivize better behavior? You can't reduce that down into a token and a mechanism. You have to have that interconnected and interoperable, not only in like every other token that exists in that system, like dependencies need to be linked, but you also need like external input. So you need to be able to design not like beyond like just a token mechanism, but like a system that says, hey, I want a formula that considers all of these parameters, reduces that down to some like it's succinct representation, which like what I'm working on is a resource that resource can then be passed through the entire network fully interoperably, and you can compute over that resource, which encodes to this entire other thing. So it's like holographic in a different way because it considers all of the vectors in which that interaction occurs. And I don't know how much of that made sense, but that's where my mind is.
It's advanced. I'll give that to you. I'd love to go deeper on it. I think it sounds very interesting. And I also think that it's fair to not make the claim that good mechanism design only has one reward vehicle. I think it's probably safe to say that tokens are one such vehicle, but there can be multiple. And as you're evaluating what those rewards can be, there's probably nothing wrong with doing multiple. But turning that into like concrete examples, I need to give more thought to. I think that perhaps the game theory of mechanism design is that we're incentivized to make the simplest but most robust possible mechanisms. And maybe that's why we keep arriving at a conclusion that one single reward vehicle is optimal, as an optimal way to do that, but by no means is it the only. Yeah.
I like the framing there that moved us from tokens, which are approaching the problem in a specific way, back to coordination as like a shared coordination layer that is the ultimate hope. So cool. I think maybe Justin could bring us on with one last question.
Cool. I was kind of having like it's so good. Thanks, Tate. I thought it was a compelling presentation, and it felt like the future and the present. I always love that feeling of like it's clean, it's taking what we're thinking and theoretically like through the kernel learning and putting it into like I think a very beautiful practice of different ways by which you can take a set of values and principles and then create rules that are really incentivizing action in a different kind of way for a whole ecosystem of people. And I think your background as deciding to approach this ecosystem or this particular project from the lens of a venture studio, particularly in your own background, to be able to support and build organizations to actually be able to, I guess, learn with and grow these mechanisms. It's kind of what possibilities there. I thought was also really compelling to me, and I just put in the chat like it's in the. I'm not sure if you can see it, but I was kind of just trying to practice the thing that you showed at the beginning, which is like, I came into my question I've been asking for a while is how can we architect an infrastructure for human development and coordination, one that harmoniously honors individuation, provides communion, serves humanity, and reveres Earth's kinship. And so you can kind of think about how we're talking about that, even with what Keisha was bringing around this kind of coordination layer across multiple dimensions, is kind of this integral approach. And so I tried to do a goal, reward, and mechanism calculation kind of thing. And I just wonder if you could give some perspective or feedback on that based on the other ways, you seem like you're really good at taking a system or taking a perspective or taking a gestalt and then breaking it down those three ways. Could you give me some feedback on how I could either maybe approach this differently or think about those three areas and more specifically?
Sure. Yeah. Thank you for the kind words first. I see you have two in there. Do you want me to respond to both or one specifically? Is one another version?
Yeah, one's another version. I was using like Notebook and Gemini to try to use more R weaving language in case my results were kind of not technical enough. But I think either you can respond to either one. I think it would be meaningful. Yeah.
Okay. Cool. Let's see here. So personal project, intentional inquiry, architecting an infrastructure for human development and coordination. Yeah, I mean, the other thing that I think regrettably I didn't talk about too much in this was the idea of DAOs. Touched on it a little bit with Beanstalk, but like the idea of decentralized coordination is an incredibly interesting problem that very few people, I think, have great solutions to that are working in practice right now. And it seems like you're trying to solve a similar problem, at least in some sense. Is that the correct way to think about it, at least from the goal standpoint?
Yes.
Okay. Okay. Yeah. So I think that the way that you're thinking about this is interesting. if I had to give some feedback to it, I would say the other part of game theory that we have to think about when we're trying to architect these types of mechanisms is understanding what these incentives look like at the individual level, but then developing a picture of those individual incentives as a group to try and predict what the group would actually do in practice. The original idea for DAOs, at least, was creating an individual incentive for people to coordinate and contribute value in exchange for value to earn tokens to do so. But the problem with that is that everyone assumes, so if we operate under the assumption that if people do that and the value of said token increases as a result of increased value being contributed to the project, what the dominant strategy actually becomes for DAOs, at least traditionally, is to do nothing, because you get to benefit from other people doing work by assuming that other people are actually operating under these incentives. Obviously, that's not the ideal path to go down, because you don't want this tragedy of the commons where no one actually does anything because everyone assumes everyone else is doing things. And so I think that that's sort of the Achilles heel in the stereotypical structure that DAOs usually take on, and an existing open question with actually how to get around. I think that if you so mechanisms to calculate reward, I think, are probably, like, the way you're thinking about that would be the potential solutions to those problems. The idea of benefiting personally. Okay. So maybe going back to Acacia's comment with like one-dimensional inputs and multi-dimensional outputs. What you're proposing is that maybe there's a financial incentive to contribute, but maybe there's also a personal incentive that is not an outcome hinged on the financial incentives alone. And if that is the case, then that does present a potential solution to the problem of tragedy of the commons, because you're earning something by contributing irrespective of what other people are doing. So I would say that the way you're thinking about that, at least at the abstract level, is probably sensible. It makes sense to me. But again, this is one of those things we could talk for hours about, and I'd like to think more about it. Maybe we have a follow-up and go deeper.
I mean, it's definitely something Kernel's hopeful about. It's something that we take inspiration from something like Y Combinator from, which is the idea that like each person or project that comes through has agency and has a very specific thing that is about primarily transforming themselves. This project, which Tate is a great example of with Arweave and now AO, is like these things we work on do work on us, and that in itself can be a really valuable, meaningful part of a life well lived, and can also have financial implications or implications on a life well lived beyond just the transformational effects, but both combining are definitely areas that seem meaningful to sit in. So this has been another conversation indicative of that. Want to be respectful of time. Tate, just thanks so much for being with us, and everyone for your contributions today. It's really great to be back in conversation with you, and we'll be in touch with everybody soon.
Thank you for having me again. Yeah, I really appreciate it, guys. I hope this was at least somewhat interesting. It is to me. Yeah, thank you.
Thanks, Tate.
Thank you.
Take care, everybody. Bye-bye.